In order to better understand Yarn, let's go back to Hadoop cluster diagram that we have already seen. But this time, let's take a look at a different set of daemons. As with HDFS, Yarn runs its coordination daemon called Resource Manager on one of the master nodes number 2 in our case. Also, there's a whole bunch of node manager daemons collocated with data nodes running on worker nodes, worker node 1 to worker node 7. Let's start by zooming in on the Resource Manager first. The Resource Manager component provides a number of services that perform three main duties. First, there is scheduling, then there is node management, and then there is security. The Yarn scheduling is a single component that controls resource usage according to parameters set by Hadoop administrators. This allows for greater efficiency by allowing different organizations to use a centrally pooled set of cluster resources, also known as cluster multi-tenancy. In a multi-tenant scenario, we want all resources to be conceptually available to all the tenants, while at the same time controlling each tenant's quota of the resource utilization. This ensures that each organization can be guaranteed the minimum required resource needed in order to meet their SLAs, and also at the same time, this allows organizations to access excess capacity that is not being used by anybody else on the cluster, thus providing elasticity and lower total cost of ownership. The scheduling mechanism used and specific settings for that scheduling mechanism are under the control of Hadoop administrators, and we will review those in great details a bit later. Aside from scheduling cluster resources, Resource Manager also provides coordination of node managers. This is actually very similar to how HDFS's name node coordinates all of the data nodes. Just like name node, the Resource Manager is doing so by monitoring node managers for heartbeats, sent by node manager every second by default and expected within 10 minutes, and verifying that resource containers were actually launched on appropriate node managers within 10 minutes again, and that attempts to restart, if required, are being made. Finally, Resource Manager is also providing a few security capabilities, which are especially important in a multi-tenant environment. That's how Yarn makes sure that users cannot compromise each other's resources. The Resource Manager serves as a web application proxy and controls access to resources via access control lists, ACLs. It also manages resources and application security via token-based system. This allows Resource Manager to schedule various tasks on different nodes in the cluster based on the user requests, and one such task has a special role. It is called Application Master. Now, strictly speaking, an Application Master is not a daemon like Data Node or Node Manager. It is a user-submitted piece of functionality that bootstraps the rest of the applications running on Yarn. Now, if this architecture makes your head spin, let me walk you through a detailed interaction between the three major parts of Yarn: Resource Manager, Node Manager, and an Application Master. And I will do so by giving you a very practical example. But first, let's take a look at the Node Manager, because that's where the actual work happens. The Yarn Node Manager is a daemon service that runs on each worker node, and it manages local resources on behalf of the requesting services, such as Resource Manager and, as we will see later, Application Masters. In addition, it tracks the health of the node and communicates its status to the Resource Manager. It almost always runs next to the data node to be able to take advantage of data locality of the blocks stored on the same node. The chief duty of a node manager is to use the available CPU and RAM capacity on the node to run code, typically written in Java, given to it by Yarn scheduling requests. The whole process typically begins with a Resource Manager, a Yarn coordination daemon we've just seen, sending a code execution request to a node manager. Node manager reacts to any valid request like that by allocating required amounts of CPU and RAM capacity and spinning off a Yarn container that can now use that much CPU and RAM for running user-submitted code. This container should not be confused with Linux containers, and since it plays a very important role in Yarn, we need to understand it a bit better. So let's zoom in. A container is a unit of work within a Yarn application that is allocated specific CPU and memory resources by the node manager on behalf of the Resource Manager. The container is the component that performs the work of the specific Yarn application. A container is also launched each time a new application master required, and the request is made by the Resource Manager. When a job is executed, the application master requests additional resources from the Resource Manager via the node manager on which it is running. If additional resources can be allotted, the Resource Manager can then request additional containers to run all the tasks across the cluster. So let's go back to the node manager. The first piece of user-submitted code that starts running inside of a freshly minted Yarn container is an application master. Let's look into what this code is all about. First thing to note is that even though it may seem like an application master is one of the Yarn permanent services, it isn't one. It isn't a permanent service assigned to a node, but rather a transient service that is created as part of launching any Yarn application. The application master component serves as the bootstrap process that launches and manages everything for a Yarn application once it gets past the application submission process and to its own launch. Each Yarn application has its own type of application master. For example, Pig jobs require different application master code than Hive, and the Hive and Pig application master code would be very different from Storm application master, let's say. Each application master then is an instance of an application's framework-specific library of code, and it comes from the client, not from Hadoop itself. This is also why Resource Manager has to be very careful not to trust application master code blindly. From a security perspective, application masters are essentially user code that may or may not be validated depending on what an organization allows on their Hadoop clusters. Because of this, the Yarn platform, Resource Manager, and Node Manager components have to protect itself from faulty or malicious application masters and the resources granted to them at all costs. Even though the application master is responsible for a significant amount of monitoring and management, it is actually not a privileged service. All requests for resource and containers must be granted and executed by the Resource Manager and Node Manager components. Once the application master is set up and running, it is responsible for negotiating appropriate resources in form of containers from the Resource Manager, working with node managers to execute and monitor containers and their resource consumption, determining the resource allocation per container, and finally providing fault tolerance for applications. Many of the tasks traditionally performed by a cluster-level resource manager are now actually pushed down to the application layer via the implementation of the particular application master. The global resource manager component is responsible for monitoring, tracking, and approving resource allocation requests, but once those requests are granted, the application master handles all of the heavy lifting in terms of communicating with node managers, tracking specific resource usage for the application, allocating and deallocating containers, and general progress monitoring for the application itself. The application master is also responsible for application's fault tolerance, which critically means that the global resource manager is not responsible for this function anymore, and that makes it a pure scheduler. Moving all of these functions out of a centralized resource manager component into the worker node layer allows for massive scalability to the tune of tens of thousands of nodes, since the central resource manager is not nearly as much of a bottleneck as it otherwise would have been, and actually was, in previous versions of Hadoop. But let's get back to our example. One of the first things that an application master will do is to talk to the resource manager and negotiate extra resources. After all, this is an application master for distributed computation, and running in a single container on a single node manager is just not much fun at all. The request, after being checked against the policy, is typically granted, and an application master can now send a validated request to a node manager. From a node manager standpoint, this is just a regular request for allocating a container. Node manager doesn't really care where that request came from, as long as it is validated. In other words, this request is no different from the first one that came from the resource manager itself and bootstrapped this very example. Also note that in our case, we're showing you that a request for an extra container came to the same node manager on which the application master itself is running. It actually doesn't have to be the case. It could have been a different node manager running on another worker node. But back to our node manager. After checking the request for validity, it allocates a container just like it did when a similar request came from the resource manager itself. The application is now considered to be up and running, and it will do certain tasks utilizing CPU and RAM resources of the cluster via allocated containers. Now, before we finish our review of all the moving pieces of Yarn, let's see how containers, application masters, and job tasks might be spread across a 3-nodes cluster. In this example, the job 1 application master was started on node manager 2. The first task for job 1 was started on node manager 1, and the second job 1 task was started on node manager 2. This completed all the tasks required for job 1. Then the job 2 comes. The job 2 application master was launched on node manager 3. The first two job tasks were launched on Node Manager 1, and again, Node Manager 1, and job 2 tasks 3 through 6 were launched on Node Manager 3, and the final job 2 task was launched back on Node Manager 1. The main point in this is to illustrate that the application master can initiate the creation of containers on any appropriate node manager in the cluster. The default behavior is for all jobs to be collocated where data blocks already exist, even if more processing power is available on a node without those data blocks elsewhere in the cluster. Remember we told you that Yarn is responsible for making Hadoop's mantra of bringing computation to the data true? Well, this is how it does it.